So in the diagram, we have a trapezium with blah, 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 blah. Okay, this is important because they haven't given us this on the diagram. So that is important, of course. But for the most part, I don't really enjoy reading all that diagram, those things. Okay, so UZ is 4. Now, guys, remember that they're not saying 4 centimeters and 7 centimeters. They are using a ratio. So because of that, you are going to put a 4x over here or a 4y, whatever you want. And then they're telling us that YZ is 7. So this length over here is 7. Now, I don't know why, but I don't like labeling my diagrams like that. What I rather do is if I know the total length is 7, then I know that this is 3. And in my opinion, it is better to do it this way because it just makes your diagram look easier to, it makes it look neater. And it's also much easier to work with when you do it like that. Okay, but you don't have to, but it does work better. Trust me. Right, you don't have to worry about, yeah, but now Kevin, doesn't that mean I'm going to get a different answer? Not at all, guys. Mathematically, it's all the same thing. So here's our first question. Prove that YV, okay, so what I would do in a test is I would go highlight YV, okay, YV, and over VW, okay, VW, there's VW, is the same as XV, okay, let's use, sometimes it's difficult to know whether we should use a different color or not, over VZ. All right, guys, so what I see is the following. A bit weird. It is very weird, but what if we do this? When I was looking at this and I looked at YV over VW, where's that? YV over VW. Look at YV over VW carefully, and let's take away the rest of this. Okay, so now what I want you to do is focus in on this triangle over here. Let me just get it for you guys. Okay, look at that triangle. And remember that they are giving us parallel lines. So there's probably some type of proportionality theorem happening over here. Okay, if we look in that triangle, guys, let's quickly highlight those parallel lines as well in a different color. I think that might make it pop a bit more. Let's just see. Okay, so remember the basics of proportionality. If you have a triangle and you have parallel lines, and this is like A, this is B, this is C, this is D, you can say a whole bunch of things like A over B is the same as C over D, or I don't know, there's a whole bunch of different things you can say, right? So I want you to look at this red triangle. We're sort of looking at it on its side, but can you see that we can say this one over, or let's start with YV. So we can say YV over VW, right, would be the same as YU over UZ. Okay, make sure that you can see that. It is a bit weird. Your neck's probably like breaking right now, but it's all good. We got to do what we got to do, hey? So let's go write that down so long. So we can say that in triangle YZW, then we can say that YV over VW is the same as YU over UZ, right? And now there's many different reasons, or in fact, there's two main reasons you can use. You can use prop theorem, and then you're going to say which lines are parallel. So you could say like UV is parallel to ZW. All right. Your other reason, and I think the more popular reason that I've noticed students in South Africa like to use is line parallel side of triangle, and then also just give the sides that are parallel. So you can use whichever one you prefer. Okay. So that's what we have so far, guys. We have YV over VW, and I'm happy about that. The reason I'm happy about that is because I can see that that's part of this thing over here. So at least we've got that. Now we're going to go work in a different triangle. Oh, by the way, let me just actually reverse that. Because YV over VW is now the same as YU over UZ, it means that this part here can also be a 3, but you must use a different letter. So like 3y, for example. And then this part over here would be 4y, for example. Okay, we might not need that, but I think let's just keep that for now. Okay, so yeah, so and then you guys can choose whichever one of these you prefer. All right, so now guys, what we're going to do now is let's go back to the original thing. Now we're also looking for xv over vz, xv over vz. So let me show you something quite interesting. xv over vz. So let's quickly highlight that. So let's try use parallel lines. So guys, this is what you got to do. You got to try use parallel lines, okay? And you got to try use xv and vz. Well done if you can identify that this might be a triangle that we can now work in. Okay, because now what we have is we've got parallel lines once again, which is good for proportionality theorem. And we also have the ability to get xv over vz. So that's quite nice. So now we can say in triangle XYZ, we can then say that XV over VZ. See, I like to get XV over VZ because that's what we have over here. So that's good. It could help us. And what we're going to see is that that is equal to, so XV over VZ should be the same as YU over UZ, right? And that's also just going to be line, parallel, side of triangle. And then the parallel lines here will be XY parallel to UV. Okay. And so what we should identify now is that we got the YV over VW. We got the XV over VZ. Now, what you should identify is that we made both of those things equal to YU over UZ. And so because they are equal to YU over UZ, it means that this part and this part must also be equal to each other. So we can then say, therefore, YV over VW must be the same as XV over VZ. By the way, because we've now said this over here, we can go for in YU as a different ratio, just in case we need it. I'm not sure, but maybe we can fill this one is YV in as 3W, and then VZ, yeah, VZ is 4W. Okay, just in case we need it for later, because now we've got all these ratios, so that's fantastic. So let's get rid of all of this stuff. Okay, so this question says, determine the numerical value of the area of XVY. So let's go find that triangle quickly. XVY. XVY, where are you? Here you are. Okay, XVY, and then triangle WVZ. WVZ, where are you? Oh, you here. W, V, and Z. Right. Now, guys, remember, there are only two ways to be able to answer these area questions. That is either, number one, using a common height. Then we use the formula half base times height. Or number two, we use a common angle. And that's where we use half AB sin of angle C. Okay. So you got to look at the two triangles that they've given us, and you got to ask yourself, what do they have? Do they have a common angle, or do they have a common height? Well, they definitely don't have a common height, but they do have the same angle. It's not a common angle really, but it's the same. We've got V2 would be exactly the same as V5 because of vertically opposite angles. So we're not going to use option number one. We're rather going to use option number 2. So what we can go do then is we can say that the area of triangle XVY over the area of triangle WVZ is going to be a half. Now we're going to use the area rule on this red triangle. So that's going to be a half times 3W multiplied by 3Y multiplied by the sin of angle V2. Okay, see what I've done there? I've just used the area rule on that triangle over there. Now I'm going to fill in the sin rule for the green triangle. Let's do it in green. So that's a half times 4W times 4Y times the sin of angle V5. Now you would probably have to explain to the examiner that angle V2 is equal to angle V5 because they are vertically opposite. Okay. And so for that reason, these things are exactly the same. So we can cancel those out. And what we can also cancel out now is the halves, the W's, the Y's. And so what we are actually left with now is 3 times 3, which is 9, over 4 times 4, which is 16. And that is how we get the answer of 9 over 16. Right, so this one says, show that WXYZ, so this entire shape, is a cyclic quadrilateral. Now, guys, how do we prove that something is a cyclic quadrilateral? 3 techniques, okay? So how to prove a cyclic quad? Okay, so number 1, we do something like this. If you can see that the opposite angles equal 180, then it's a cyclic quad. Okay, let me rather make that a little bit more user-friendly. If A plus B equals 180, then it's a cyclic quad. Okay, number 2, it's when we use the exterior angle. So that, for example, would be something like if A and then B. So if A is equal to B, then it's a cyclic quad. And then take some notes. Number 3, probably the most popular one that they ask in exams. Out of every 10 cyclic quad questions, this one will be asked 9 times. So that's the one that looks like this. So whenever they have a cyclic quadrilateral like that, and then they've got these diagonal lines going through, the way that you would prove that something is a cyclic quad when you have it like this, for example, is you would prove that angle A is equal to angle B. So angle A is equal to angle B. Then we call this the converse of angles in the same segment. That's the most popular one that I've seen people that I've seen them ask. So what I always tell students to do, and some of you have heard me say this before, when you are in an exam and they're asking you to prove if something is a cyclic quad, have a look at the cyclic quad. And then if there are diagonal lines, aka these ones, then I can guarantee you 90% of the time, it's going to be this one over here that you're going to use. Okay. They hardly ever use these ones. All right. Right, guys. So let's see how we can prove that this one is a cyclic quadrilateral. I think it's going to be the one where we prove the angles in the same segment. So for example, we could take this line down here at the bottom, this line here. And if we had to look at angles on the same segment, what that would look like is it would go something like this way. Okay. And like this. So if this thing is a cyclic quadrilateral, then we would be able to show that this angle is the same as that angle. If we can do that, it's a cyclic quadrilateral. However, you could also use this in a different way. You could try doing it like this maybe. You could use this part over, you could start at this point. And then the two sides that you would try to prove would be this one here, right? And this one here. So then it would be this angle and that angle. So those are just some examples of the way that you could do this, okay? You got to try some angles in the same segment. I'll show you one more possibility. You could use this as your base, and then your angles in the same segment would then be down this way and then down this way. So then you'd have to try prove that those angles are the same. And then lastly, just because I'm feeling a bit OCD, I would like to show you all of the possibilities. You could also use, this one as your base, and then the angles that you would prove would then have to be, you'd go this way and this way. So then the angles that you would prove would be this one and that one. Okay, so if you can get any one of those to work, then you have proved that it's a cyclic quad. All right, so I'm going to start at the bottom. I'm going to start at the bottom. So that would be down here. Boom. And so what we got to try prove now, guys, if this is to be a cyclic quad, is we'd have to somehow try prove that this angle is the same as this angle. So check this out. What we could say is that, and remember that these lines are parallel. So I'm going to start off by saying that because there's something we haven't looked at yet, and I forgot to mention it to you guys. They also tell us that V3 is the same as V4. So these two angles are the same. Okay. Now, okay. If you look over, let me get a different color for us. Can you see that there is an alternating angle over here? I mean, not an alternating angle. There's corresponding angles there. Can you see that F that I've just drawn? That would tell us that X1 is the same as V4. Okay, I think let's start there. Let's see what happens. X1 equals V4. Why? Because of corresponding angles. Why? Because the line XY is parallel to UV. Okay. Then the reason I went for V4, guys, so I know that I want something to do at this angle and something to do at this angle. And I also want to use this V4 and V3 because obviously they've told us that for some strange reason. So what I'm going to do now is I'm going to say that V4 is the same as V3. Why? Because they gave us that. That's given. Remember, they gave that to us over here. And then what we can do, let's get rid of this corresponding part now. We could look at this corresponding angle. See that? And so we can then say that angle V3 is the same as W2 because of corresponding angles. Why? Because UV is parallel to WZ. And so guys, if you follow the pattern, we said X1 is the same as V4. V4 is the same as V3. V3 is the same as W2. So that means X1 must be the same as W2. So we can say, therefore, X1 is the same as W2. And therefore, WXYZ is a cyclic quad. And the reason for that would just be converse of angles in same segment. So this question says, prove that, and this is a classic, they love to ask this question, and it always gets solved in the exact same way using tan chord theorem. Let me show you. Prove that UV is a tangent to the circle passing through XVY. So we're going to draw a circle through XVY. So we try to make it as neat as possible. Okay, that's not too bad. And okay, so there's circle XVY. Now they want us to look at this line UV. So where's UV? Oh, here it is. And they want that line to be a tangent. So guys, you need to think about the tan chord theorem. The way the tan chord theorem works is that if you have a circle and you have a tangent and you have a chord, okay, then this angle in between the tangent and the chord will always be the same as any other angle that is made by that chord there. So these two angles are the same. So then in this scenario, look at the blue circle and look at the red tangent. You need a chord. So that chord would be this one over here. This one here. Can you see me drawing it? This one. There we go. Then what you do is you look at the angle in between, which is this one here. And you look at where that chord is going. So that chord is going here. So what we need to try and prove is that X1 is the same as V3. But if you can remember already, we have already proven that. Okay, yeah, if you can remember, we've already done that. Because we said that this angle, we said that X1 was the same as V4, remember? But then V4 was already the same as V3. We have already done this. So we can say that UV is a tangent because, yeah, we can say that, sorry, we can say that V3 is the same as X1, and that was already proven earlier, okay? And then you can say, therefore, UV is a tangent, and then your reason would be converse, because it's the opposite of the tan chord theorem.